This is the recording to show some examples for determining the density of a couple of objects, and I realized that these perhaps are the ones that I'm sending with the lab package, and so I'm not going to use those, not to give answers away, but instead I'm going to use a copper cube, and I'm going to use these steel screws as an example for an object that does not have nice dimensions to measure. So let's get started. First I'm going to measure the dimensions of this copper cube with the caliper, and I'm coming up with 2.53 centimeters. And since it's a cube, this one here is also 2.53 centimeters, and then I need this one here, height, and again, since it's a cube, yep, 2.53 centimeters all the way through, with an error of 0.005 centimeters because I cannot measure any more accurately. Okay, the mass. So I put it on the balance, and then I have these here. Let's see, there's 50 gram, and another 20, and another 20, and another 10, so that's 100. Let's see what I got here. 120, 140, and everything slips. And that's okay, we just keep taping. Let's see. And that's actually too much. So where we are, that's still too much. Okay, let's see, how much do I have at this point? 90, 110, 130, 140, and that is too much. So 130, 135. Let's see, again 90, 110, 130, 135, yeah. 137. 138. Boy, that's really pushing it here. 139 grams, and with an error of plus minus 0.5 grams because I cannot measure any more accurately. Okay, and then I'm going to do the calculations for the density later. The other one are these steel screws. These are that's the object that has an irregular shape, so I cannot measure the dimensions, but I have to do something else in a moment. First, I'm just going to determine the mass, and everything slides, and I think I'm going to do it differently. Again, you can just keep filming. Totally horizontal, is it? A little bit better, right? Like that. Looks okay to you? I think so, right? Okay. I'm not going to slip. Okay, I'm going to start with the 50. And that's 70 together. That's 90 together, 110, 130, 140, 150, 160, 170, okay, 190, 180, 175, okay. 170, 172, 173. That looks pretty good, right? Okay, so 173 is the mass for these steel screws. And then I would need to know how much volume these have, but I cannot obviously measure this very easy at all. It would be pretty tough, so I'm going to use a different method, and that is using the buoyancy in water reduces the, so to say, reduces the weight of these steel screws. And I can use that buoyancy in two different ways. One of them would be I could fill water in both of these here and then immerse it here and measure the immersed mass, or I can measure the effective mass, and that's what I'm going to do, simply because these screws are a little bit too big for these containers. They wouldn't fit nicely in here. Well, they could just about work, but I really have to fill it up. So I'm going to use the other method, which is the effective mass. Also uses the buoyancy of water, and so I'm going to put them in here, and as I put them in here, of course the spring scale is going to measure less, and that is called the effective mass. I have to make sure that it doesn't touch the bottom and that it's totally immersed in water, and I'm measuring 145 plus minus 3 grams, I want to say. So 145 plus minus 3 grams. And because I cannot measure any more accurately. Okay, and those are the measurements, and then I'm going to do the calculations for the density. And of course, with the objects that are supplied in the lab kit, which maybe these here, or in the future semester I might change them a little bit. Of course, you measure them the same way with the caliper, measure them the same way on the scale, respectively immerse them in water to get the effective mass, or if you want to, the immersed mass. This one here almost looks like you need a bigger bucket. Okay, thanks.